Hi all, today I have a homemade weighing balance. It's made with coconut shells, but I'm not going to teach how to make this weighing balance. It's very easy, you can try it. In my previous video I told you about what is an atom, element and a compound. So today we will study about how to measure atom. Is it possible? Can I use this weighing balance and measure an atom? So if I have one paper written carbon atom here, I will put a carbon atom. Can I put 1 kg or 2 kg weight in this? No, we cannot do it. So as atom is not visible to naked eye, it is not possible to measure it. So our scientists have done work for us how to measure it. So if you think this circle is a carbon atom, so I have drawn lines in order to make sections. I made it into 12 parts. Though they are not equal, actually they are 12 equal parts. So 1 by 12th part, that means if carbon atom, if you think it is a pizza, and if this pizza is made to 12 pieces and one piece we take to eat, right? So that 1 by 12th part of carbon atom is equal to 1 atomic mass unit. Okay, so in periodic table we have atoms, elements. So according to atomic numbers, atomic masses, for example carbon 12, nitrogen 14, oxygen 16. So this way atomic masses are given. So these atomic masses, if we say for carbon is equal to 12 AMU, that means 12 atomic mass. Suppose if I put a carbon atom on one side of the weighing balance. One side of the weighing balance, if I put a carbon atom, okay, so the other side I should put 12 atomic mass units. In one side if I put in the weighing balance one nitrogen atom, then on the other side I should put 14 atomic mass units. But this is not possible. So in lab the powders which are there in the form of like salts, so they should be measured in grams only. So as weighing balance we cannot measure atoms or in atomic mass units. So whatever the masses AMU is there, we are calling it as relative atomic mass, because this is found by comparing with one atomic mass of unit, one atomic mass unit, by comparing it as a standard. 1/12th carbon atom is equal to 1 atomic mass unit. By taking this standard, all the other atomic masses are given. So it is a relative atomic mass. Then comes gram atomic mass. So this story goes on now. Very interesting, right? So we have atomic mass unit with which we cannot measure. In the lab it is not possible to do experiments. So this gram atomic mass came into picture. That means 12 grams of carbon atom is equal to 6.023 into 10 power 23. You can note it, or otherwise after at the end of the video I will show the numericals. So 12 grams of carbon atom is equal to 6.023 into 10 power 23 atoms. So this is Avogadro number. 6.023 into 10 power 23 is Avogadro number. So for carbon, gram atomic mass is 12 grams. That means if you are taking a weighing balance and if you put 12 grams of, not this weighing balance, electrical weighing balance, electronic one. So 12 grams if you put to weigh, then that 12 grams salt, like in a spoon if you take, you can take 12 grams. That much amount has 6.02 into 10 power 23 atoms in it. Very interesting, no? So this person Avogadro found. So it is called as Avogadro constant. So based on this Avogadro number, so further now 6.023 into 10 power 23 atoms is equal to 12 grams of carbon atom, means how many grams will be one carbon atom? How many grams can be one carbon atom? So it will be 12 by 6.023 into 10 power 23. So the value will be 1.67 into 10 power minus 24 grams. Don't worry, at the end of the video I will show all these numericals. But I hope you understood what is atomic mass unit, how it was found, and why gram atomic mass is required. If you measure for a molecule, it will be gram molecular mass. So as I told you, relative atomic mass. So this is the atomic mass we get by comparing with 1 by 12th part of a carbon atom. So nitrogen is 14 atomic mass units, means that 1 by 12th of carbon atom is 1 atomic mass unit. So 14 times of 1 atomic mass unit, 14 atomic mass units is nitrogen. 16 atomic mass units is oxygen. So as this was not possible, so in lab 12 grams of carbon atom is called as gram atomic mass of carbon. 14 grams of nitrogen atom is called as gram atomic mass of nitrogen, or 16 grams of oxygen atom gram atomic mass of oxygen. So later on Avogadro gave this Avogadro number named after him 6.022 or 23. Some textbooks we have 22, some 23. 6.022 or 23 into 10 power 28 atoms. That means, as I told you, if we take 12 grams of carbon in hand or a salt, or if we measure, so that amount has 6.023 into 10 power 28 atoms. So it can be anything, 12 grams of carbon or 14 grams of nitrogen or 16 grams of oxygen. Any atomic mass you take or any molecular mass you take, they contain 6.023 into 10 power 23 if they are atomic mass atoms. If they are molecular mass, molecules. So this is a measurement compared to Avogadro number. So now we know that 1 atomic mass unit is equal to 1/12 of carbon atom, and we also know from here, from gram atomic mass, 12 grams is equal to 6.023 into 10 power 23 atoms. So from this we get an equation, 1 carbon atom is equal to 12 by 6.023 into 10 power 3. How? Because 12 grams of carbon contains 6.023 into 10 power 23 atoms. That means if we want 1 carbon atom, just do crisscross, we will get 12 by 6.023 into 10 power 23. Now we want, what is this 1 atomic mass unit, how we can convert into grams. So as we have equation 1 by 12 into carbon atom. So what is this carbon atom now? We got, that is 12 by 6.023 into 10 power 23. Just substitute over here. We will get 12 by 6.023 into 23, where 12 and 12 will get cancelled, and we get 1 AMU is equal to 1.67 into 10 power minus 24 grams. That means in weighing balance, if we put on one side 1 atomic mass unit, the other side the amount of carbon should be 1.67 into 10 power minus 24 grams. So 1 AMU is equal to 1.67 into 10 power minus 24 grams. Or you can also note down one formula. 1 AMU is equal to 1 by Avogadro number. So 1 by Avogadro number, 1 AMU is equal to 1 by Avogadro number is also one formula which we can use in IIT from 6th to 10th. These mole concepts questions comes. So there we can use these formulas. So we got a standard equation over here. 1 atomic mass unit is equal to 1.67 into 10 power minus 24 grams. Now one carbon atom's atomic mass unit is equal to 12 into 1.67 into 10 power minus 24. You need to understand this because this will help you in problems. So if one carbon's atomic mass unit is 12 into 1.67 into 10 power minus 24, calculate it for nitrogen. For nitrogen it will be 14. So 14 into 16.7 into 10 power minus 24. For oxygen it will be 16. So 16 into 1.67 into 10 power minus 24. For example, if you take any molecule like carbon dioxide or methane or anything like that, any molecule form if you take, then that amount into that mass into 1.16.7 into 10 power minus 24. Sorry, this is not 16, this is 1.67 into 10 power minus 24. So this way we need to calculate for atoms atomic mass, but if we can calculate it by taking gram atomic mass, we can calculate it by taking gram molecular mass. So connected to this we have mole concept, that is about moles. So this gram atomic mass or gram molecular mass, we can also say it is equal to 1 mole. So for our convenience in the lab, so this mole is used for the experiments. So this mole is a unit where 1 mole is equal to gram atomic mass or gram molecular mass. You know in detail what is gram atomic mass. Gram atomic mass is mass of an atom. For carbon 12, for oxygen 16, for nitrogen 14. Gram molecular mass, for NaCl it is a molecule. So for molecule NaCl it is 58 grams. So this way we need to calculate gram atomic mass or gram molecular mass, which is equal to 1 mole. So this is a formula given in terms of mass of an atom or a molecule. Okay, very important point. Then next, second point is 1 mole is equal to Avogadro number. And one more important thing where we get confused is if atoms are given or molecules are given or particles are given. So no need to get confused. So if atom is given, then it will be Avogadro number and atoms. If molecule is given, so Avogadro number 6.023 into 10 power 23, so and so molecules. So let us take one example for this. So 1 mole of salt if we take, which is equal to, that's for example NaCl is the salt, which is 58 grams in weight. So 58 grams of salt you have taken on a weighing machine and you have weighed, it is 58 grams. So divided by 1 molecule of NaCl. What is 1 molecule of NaCl? Its molecular, like gram molecular mass is 58 atomic mass units. Okay, so if we calculate the mass, we will get it as 58. So because sodium is 23 and chlorine is 35.5, so if we add, we get around 58.5 into our conversion which we have done. We have to use here 1 AMU is equal to 1.67 into 10 power minus 24, because we are converting into grams. So to convert atomic mass units to grams, we need to multiply with 1.67 into 10 power minus 24, which will be equal to again our Avogadro number 6.023 into 10 to the power of 23. That is the reason I said if we are taking an atom like this, carbon atom, we are getting 6.023 into 10 power 23 atoms. Here one example is there. Same way if you are taking a molecule or particles, 6.023 into 10 power 23 molecules. Now this is a special case where gas only applies for gas. So at standard temperature and pressure, if oxygen gas is taken, for example, 22.4 liters of gas is equal to 1 mole. That means the oxygen gas occupies volume of 22.4 liters, which is equal to 1 mole. So only for gases it applies. So I hope you got a clear idea about all the formulas, and if you get this type of questions, mole concept or relative atomic mass or gram atomic mass, I think you will be clearly able to solve all the problems related to this. Thank you.